Pierre-Antoine Champin, who is going to tell us about semantic interoperability at W3C, what's there, what's missing, and what's coming. So, Pierre-Antoine, very good afternoon to you. Take it away.
Thank you very much, Jennifer. Thank you all for having me. And so I will be presenting the state of activity on the topic of semantic interoperability at W3C.
I think you're on mute. We can see you and see your slides, but we can't hear you.
Sorry very much. So yeah, WebEx was just telling me that I should unmute. I thought I did. Sorry for that. Can you hear me correctly now? Can you hear me?
Yeah, we can hear you now.
Yeah. Okay, wonderful. So thank you, Jennifer, for the nice introduction. As you said, I work for the World Wide Web Consortium, also known as W3C. I work there as a fellow, meaning that I'm actually affiliated with a W3C member organization, in that case, Inria, the French Research Center for Computer Science, who's donating my time so that I can operate on the W3C team. Before that, I've been involved in standardization work, especially at W3C for a long time, first as an outside observer, then as an official participant working group, and since 2 years now as a member of the team. Okay, I got it. I mute myself when I try to change slides because I'm on the wrong window. This should be fixed now. Before I dive into the topic, I won't be presenting in detail how W3C works. If you're interested in this, I will cover briefly this. Well, we cover this topic in the panel later on this afternoon. But in my presentation, I will be using some of the W3C jargon, which I need to introduce briefly here. There are a number of different kinds of groups operating at W3C, but I will be focusing on two of them. Working groups are the most important ones, as they produce the W3C recommendation, which is the name that we give to our standard specifications. In order to do so, working groups have a strict process. They are chartered for a specific period of time, and the charter also dictates what recommendations or other documents the working group is supposed to produce. On the other end of the spectrum, we have community groups, or CGs. Those are much more flexible and open. As a matter of fact, anyone, not just W3C members, can participate or even create community groups. And the goal of those groups is to explore new topics that may not be strictly ready for standardization yet, and possibly incubate future standard work. As a matter of fact, a number of working groups nowadays work on the basis of work that has been produced inside community groups. For these community groups have the ability to publish community group reports, which are published on the website w3.org, which gives them quite some visibility, although they are not standards, they are not officially endorsed by W3C. And yet some very active community groups have published reports that have become, over time, very influential, even though they are not yet, they have not yet become officially recommendation. So once this vocabulary things is out of the way, my talk will be structured in 4 parts, and I will focus on what's not to be perceived as different kinds of categories of data, because any piece of data might fall under several of those, if not all, in some cases. So think of those 4 parts more as 4 perspectives on data. Therefore, I talked about linked data, about metadata, authentic data, and decentralized data. So linked data is collective name of a set of standards published by W3C over almost 3 decades now, that aim to describe how data is to be exchanged on the web at web scale and in an interoperable way. There's a number of specification already existing, as I said, published over a number of years, which are summarized here. In the center of it, we have all the recommendations related to RDF, which is a resource description framework, the core data model of the web of linked data. And around that, so RDF itself is made of several standards describing its abstract syntax, its semantics, and several concrete syntaxes for encoding RDF data in multiple ways. And around this, we have other standards for querying RDF data, validating RDF data, or reasoning with RDF data. All the standards mentioned, well, sorry, most of the standards mentioned in this slide have been published around 2014. So they're getting a little old. There are a few exceptions. Shackles is, I think, 2018. JSON-LD, I will talk about it in a moment. But most of these standards have been around for a while. That means that they're mature, and that's a good thing, but it also means that their use cases have been evolving over this time, and some of them need to be updated. But let's first focus about JSON-LD. JSON-LD is one of the multiple concrete syntaxes for RDF. It can be seen as a way to encode RDF data using the very popular JSON syntax. That's one way to look at it. That might not be the most interesting way to look at it. Another way to look at JSON-LD is a way to interpret JSON data as if it was RDF data. And that includes legacy JSON data that was not intended in the first place to be JSON-LD. I'll come back to this later, but that's a very important perspective on JSON-LD. So as I said, JSON-LD is an exception. In the previous slide, it's been updated relatively recently compared to the other. JSON-LD 1.1 dates back to 2020. And we are in a situation here where we have actually one working group and one community group working on JSON-LD. The working group is still active, but in what we call maintenance mode, meaning that it's not chartered to produce any new standards at the moment, but mostly to maintain the existing recommendation. A number of errata have been raised by people using JSON-LD in their work, and the goal of the working group is to record those errata, apply the editorial changes to the specification, and eventually to publish a revised version of JSON-LD 1.1. On the other hand, the JSON-LD community group has been very active in the past year or so, exploring new topics, and one of them being YAML-LD. Not sure if you've heard of YAML before. I guess many people have. Initially, YAML meant yet another markup language, and that's really what it is in a sense. So YAML has been quite popular recently. It's perceived as being more user-friendly and easier to author than JSON, while being very similar in its underlying data model. And therefore, the idea is to benefit from this user-friendliness and ease of use of YAML data and provide the same, let's say, the same services as those that JSON-LD provides for JSON, namely being able to interpret YAML data, YAML legacy data, as if it was RDF. And because the data models are so close, this is actually a rather low-hanging fruit. So this is really work in progress currently in the JSON-LD community group. I didn't mention that all this presentation will be shared. All the links that appear here are actually, well, all the colored text are actually links, and if you're interested, you can follow these links and see more. Another active working group that has been created quite recently is the RDF Star working group. So the mission, the very ambitious mission of the RDF Star working group is to extend RDF and Sparkle, so the data model and the query language, with the ability, and I realized that I should have an animation here, spoiler alert, with the ability to concisely represent and query statements about statements. So you might know that RDF data is shaped as a graph. So we have nodes representing entities and edges representing relationship between those entities. The novelty that RDF Star brings to this is the ability to have edges, not just between nodes and nodes, but also between edges and nodes, or nodes and edges, and so on. Why is it important? I mentioned that RDF has been around for a while. It can be considered quite mature. However, the landscape of data and of graph data has evolved quite a while since RDF was published. RDF 1.1 was published. And a very popular kind of graph database nowadays is property graphs. And property graphs are graph data, just like RDF, but they have also a number of differences. And the goal of this extension of RDF is to make it easier to bridge the gap between property graphs and RDF, and to make it easier to create more interoperability, which at the moment is quite challenging, between RDF data and property graphs. So RDF Star, this particular extension of RDF was, again, explored in a community group, and a community group report was published in 2021. And the working group was subsequently created. As I said, it was launched recently in November 2022. And its goal is, first of all, to update those RDF and Sparkle recommendations that date back to almost 10 years ago, 2014. And in the process, extending them with this new feature that RDF Star proposes. So again, a very important work, because it addresses the very core specification of the whole linked data stack. And eventually, this will have an impact on all the set of specifications that I presented earlier. That's why the mission of this group is really important, also very delicate, because we don't want to break anything in this, and yet evolution is required. Before I move on to the second part, one key message that I would like you to take home about linked data and RDF. RDF should not be thought of as a new data model that people need to adopt and therefore drop the previous data models that they were using in order to use RDF and benefit from the benefit it has to bring. This is one way to do it, but this is not the only way to do it. Another way to look at it, and this is well illustrated by JSON LD, for example, is that linked data is a way to look at existing data in a different manner. You don't have to convert or change the data formats that you're using. Linked data and RDF provide you with a way to look at them in a different way that makes it easier to interoperate with other data out there, other data that may be in different formats. By using JSON LD, you don't have to abandon JSON. You can still use your JSON data, and actually using it as plain JSON when the context allows it is absolutely okay. But the ability to look at it as if it was an RDF graph brings you more value, especially when you have to interoperate with other people's data. And the same is possible actually with other kinds of data. W3C has other standards, which were not mentioned on my previous slides, but like R2RML is a mapping language for relational databases that provides exactly the same kind of services. You keep your relational database as is, but you can choose to look at it as RDF when it makes more sense. CSV on the web is also a similar standard for schemaless tabular data, such as CSV, TSV, and all their variants. So linked data is not a competing data model. It's really an interoperability layer that can be deployed on heterogeneous data without necessarily changing it. The second part of my talk is about metadata. So as you probably know, metadata is data that talks about other data. And a very important standard in that space is DCAT, the Data Catalog Vocabulary. So DCAT is, citing the spec, an RDF vocabulary designed to facilitate interoperability between data catalogs published on the web. And DCAT has already had 2 versions published because, again, it's widely used. And when it's widely used, a number of people come up with errata, with problem issues, with new use cases, which have to be taken into account in the new version. So DCAT 2 was published in 2020 by the Dataset Exchange Working Group. This working group is still active and actually actively working on the version 3 of DCAT, which is expected to become a recommendation in roughly September 2023. But if you are interested, and I know that a number of people in the audience are, we actually have published a working draft of this recommendation very recently. And that working draft is, well, the content of the working draft should not change significantly between now and the moment that we publish the recommendation. We expect to have a candidate recommendation in spring. At that point, we will be requesting implementation reports and usage evidence, because one of the conditions to finalize a recommendation is to demonstrate that it has been implemented already. And therefore, so if you're interested, again, there's been recently a new a pre-version of DCAT 3, a working draft of the future recommendation. Another important work item of the dataset exchange working group is around the notion of profile. So again, citing the spec, the draft spec, a profile is a specification that constrains, extends, combines, or provides guidance or explanations about the usage of other specifications. So DCAT, as I said, is widely used in many domains with slightly different use cases. For that reason, DCAT is a very generic specification, which provides interoperability on a very broad scope, but the price to pay is that the level of interoperability is relatively low in order to address what is common to all those different fields. And many communities using DCAT felt the need to define a profile that is a specific way of using DCAT, of combining it with other standards in order that met their requirements more accurately. Okay, the European Commission has published DCAT AP, and we have more, so AP for application profile. Other organizations have their own profiles of DCAT. We have specialization for specific kind of data, such as STAT DCAT AP or GEO DCAT AP for geographic, statistical and geographic data, respectively. All those standards are currently defined in a rather informal way. And one work item of the Dataset Exchange Working Group is to help formalize the way profiles are defined. That's the role of the profile vocabulary, which is a working group note, meaning that it is not a normative document as a recommendation would be, but it's still there. So standardizing the way profiles are defined, but also the way profiles are used. And there is a draft recommendation that has not received much love in the past years. You can see that the latest version is from 2019 about content negotiation by profile. What that means is this draft recommendation specified how a given client can request from a server metadata that complies with one or another specific profile of DCAT. Sorry, I focused on DCAT profiles because that's where those use cases come from, but nothing in the definition of a profile is specific to DCAT, okay? Other very generic specifications can benefit and do benefit of the notion of having profiles defined on top of them. So this will be useful for DCAT. This will be useful for other generic standards. And fortunately, there has been a renewed momentum around this work item, again, very in the past weeks. So hopefully, we will see more development in this in the coming months. And this will be useful for the DCAT world. This would be also useful in other places of the linked data standards. And as a matter of fact, the RDF STAR working group, which I mentioned earlier, is very interested in this. The reason is, if RDF evolves, as I said, this will impact a lot of other standards and a lot of people that are actually using RDF in production today. So any new feature of RDF, such as the ability to make edges between edges, on the one hand, is useful because it will unlock new use cases, but on the other hand, might be disruptive to the existing technologies and use cases based on RDF. And so having the possibility to have different profiles of the future version of RDF, some of them with a restricted set of features, which is more conservative, and some of them with more advanced features, would be interesting. And therefore, the ability provided by the content negotiation by profile to automate the way a client and a server decide on which dialect, in a way, of RDF they want to speak together would be really important in that context. The third point I wanted to address is the one of authentic data, which is to be understood as data for which you can verify that they have been created by the authors that they claim to be, and verify also that they have not been modified in their way between the original author, the original creator, and you. And this is obviously a very sensitive and important topic in the world of a data economy, as we are aiming to create. And there are currently 3 active working groups at W3C working hand in hand to provide a set of standards that are useful to produce and verify authentic data. Those groups are verifiable credentials, aka VC, decentralized identifiers, aka DID, and RDF dataset canonicalization and hash, aka RCH, which we pronounce rich. Which the first of those working groups is verifiable credentials. One word about the notion of credential, which when I first came to this, I had a very narrow understanding of what credentials would be. So I might not be the only one. So when we think credentials in the IT domain, we think, well, that's the information you need to authenticate yourself on a service, okay, login password or something like that. The definition of credentials used by this working group is actually much, much broader. So a credential is a set of one or more claims made by the same entity. So you can think, for example, of a credential stating Alice was graduated from University X on a given date. Another kind of credential is Bob received his second COVID shot from this brand and this batch number on this given date it was it was performed by nurse Charlie on Bob's left arm. Credentials do not have to be necessarily about a person. They can be about a thing. For example, the car whose license plate is 1234 was passed successfully the safety regulation test for the French safety regulation test on that date, and the test was performed by this company. So all those kind of things are very important in our day-to-day lives, and digitizing this kind of credential in a way that could be also digitally verified is really important, and that's what verifiable credentials are about. Version 1.1 verifiable credentials was published in 2019 and revised in 2022. The working group is still active and actually working on further specification that are necessary for fully using verifiable credentials. This specification here is mostly the data model, okay? So the envelope in which you can put all the information, how this information is to be used, especially when it comes to verifying that the credential is authentic, is still work in progress. And despite the fact that not everything is yet standardized, verifiable credentials are already hugely deployed in many organizations. To cite just one, which is of interest to this audience, I guess, GaiaX is making already use of verifiable credentials and decentralized identifiers. Please note also that the credentials community group is also very active. It's a situation similar to JSON-LD, where we have a working group working on very specific recommendation in order to make them proper standards, but also a community group very active in exploring a lot of things around those standards. So basically, verifiable credentials, what the standard says is that a verifiable credentials is made of three parts: the claims themselves, here in the middle, some metadata, who made these claims, when they made that, and then some proof, which is cryptographic material allowing to verify the authenticity of the credentials. Now, if we want to verify that the credentials was actually created by a given agent, then we need to be able to identify this agent in an unambiguous and also verifiable way. And that's where decentralized identifiers come into play. So again, citing the specification, decentralized identifiers, or DIDs, are a new type of identifier that enable verifiable and decentralized digital identity. Decentralization here is important first for robustness. We don't want a single point of failure that would endanger the whole identity scheme that we have, because identity is so important. It has also another very important aspect, and that's sovereignty. And especially what the spec says is that the design enables the controller of a DID to prove control over it without requiring permission from any other party. Think of email addresses. Okay, they are very commonly used as identifiers nowadays. Usually, you don't have control over your email address. Your email provider, whether it is Gmail or whether it is your employer, has control over this identifier. They may decide to turn it off, and if they do, you don't have any way anymore to prove that you once controlled. Well, that you were the person identified by this identifier. So that's the kind of limitation that DIDs want to get rid of. The decentralized identifiers were recommended by W3C quite recently, last summer, in July 2022. The working group is still in maintenance mode. So again, for the moment, only chartered to maintain the existing recommendations, although a new charter is in the making as we speak, and so the working group should be renewed very soon with potentially new work items on its plate. Finally, the third of the three groups working on authentic data is the RICH working group, which aims to define a standard to uniquely and deterministically calculate the hash of an RDF dataset. This is the most low-level and technical and slightly geeky part, but this is a really important part if we want to be able. So detecting changes is one of the use cases, but of course another is to sign an RDF dataset and verifiable credentials is one particular example of an RDF dataset. So this is a key component of the proof part, the third part of the verifiable credentials, although this has also other use cases. So again, we are talking about a relatively recent working group. It was launched in the end of last year. We already have a draft recommendation for the dataset canonicalization algorithm. The last part of my talk is about decentralized data. We touched on it already a little bit with decentralized identifiers, but beyond identification, there's a massive trend of decentralizing, or rather re-decentralizing the web nowadays. The web has grown more and more centralized with big services collecting huge amounts of data in silos that raise a number of problems regarding privacy, regarding sovereignty, and also regarding interoperability, because there is very little interoperability across those silos. One element of that trend is ActivityPub. You might not have heard of ActivityPub before. However, I'm sure most people here have heard of Mastodon, which is a decentralized social platform that has gained much popularity with the recent events surrounding Twitter. And a number of so-called Twitter refugees have migrated to this application, Mastodon. Well, Mastodon is using, under the hood, the ActivityPub protocol. And what's interesting here is that ActivityPub is an open standard published by W3C some years ago. It was produced by the Social Web Working Group, which has ceased its activity in 2018. And what's important to understand is that as an open protocol, ActivityPub is not restricted to Mastodon. As a matter of fact, ActivityPub is already being used in other decentralized open source applications. There is an ActivityPub plugin for WordPress, PeerTube, which is in a nutshell to YouTube what Mastodon is to Twitter, a decentralized and open source version of it. Those open source applications are using ActivityPub and therefore are out of the box interoperable with Mastodon. So Mastodon is not just one new application. It is actually part of something bigger that some people call the Fediverse, as a portmanteau between federated and universe. And this sudden increase of popularity for Mastodon might become a game changer for the adoption of the Fediverse and ActivityPub. And a good sign of that is that a number of commercial applications have started considering implementing ActivityPub themselves. And therefore, rather than betting on gathering as many users as possible, as is the usual business model on the web, betting more on the network effect and on benefiting to some extent from the users of other platforms by becoming interoperable with them. So, as I said, the social working group is not active at the moment. It was succeeded by the Social CG community group, which has known a surge of activity with the event around Mastodon and so on. So nothing I'm not here for giving you a scoop or anything. Okay, there's nothing concrete yet around maybe a recreation of the social web working group, or a new working group taking over and revising ActivityPub. Who knows? But I wouldn't be surprised to see that happen in the coming months, given the current situation. Another effort, besides ActivityPub, in redecentralizing the web is Solid. And again, I guess that a number of people in the audience already have heard of that. Solid is a project that was initiated by Tim Berners-Lee, the inventor of the web. Since it's hard to give a birth date of Solid, but I identified some traces of it in 2010. So the goal of Solid is to redecentralize the web and give more control to end users. Tim Berners-Lee presents that as a mid-course correction of the web, given the unexpected and somewhat detrimental movement of centralization that it has known in the past decades. Solid is based on RDF and linked data platform, another part of the linked data set of specification. It was developed for a number of years in a community group, the Solid community group, which a few months ago decided to move on and spin off a working group. Again, the goal is not to replace the community group, but to be in the same situation as with Credentials or JSON LD, have a working group standardize a number of the protocols that have been proposed by the community group, and have the community group work on everything around those things, because some of the things produced by the community group are not at the same level of maturity. And anyway, Solid is a very big thing, with some part of it being ready for standardization and some maybe not. But so this working group, we are currently working on writing the charter for the future working group. A number of organizations are joining W3C because they're interested in that. So companies and governmental organizations alike. So something really interesting might be occurring here. And for some of you who have not heard about Solid, or have heard of it in a very high level way, very briefly, this is the way web applications are designed today. Users interact with different web applications, and each web application has its own database that's under the control of the application provider. So the data produced by the user first is under the control of the application providers rather than the users themselves, which for privacy reasons is not necessarily a good thing. And also the data of a single user is scattered across different databases that do not interoperate with each other and prevent the user for gaining all the value that they could get from all the data they produce using various applications. What Solid proposes is to invert this chain of control. People have a personal online data store over which they have control, and they allow application to read and write some of the data that's in the personal store. Now, all the data of the user is stored in a single place, and the user could combine data created from different applications in order to get all the value they could out of it. And they keep control of that. This creates new business models. This creates a new balance between users and application providers. And again, a number of companies are already investing, companies and governments are already investing in this. So you might want to follow this. And that's it for me. Thank you very much. And so this is the URL of this presentation. And if you have any question.
Well, thank you very much, Pierre-Antoine. Quite detailed and a lot of content there. So I think you covered an awful lot of ground, but we do have a few questions that have come in from our audience. Referring back to an earlier point you made about the objective of content negotiation protocol, one of our audience members is saying it was probably not sufficiently promoted. And do you have any use cases worth mentioning other than web related?
So, short answer is no, I can't think of at the moment. I apologize for that. Again, well, we are focused on the web. That's what we do.
Yeah.
I, I can. So I'm not sure what this person has in mind when something that's not web related. I mean, the web now has become the preferred way of exchanging data. So I think this is the right place to make this kind of standards. But so yeah, that's what
Okay.
we're focusing on, I'm afraid.
Okay, we've also got a couple of comments around the semantic stack. Somebody a little bit nostalgic saying anybody who remembers the first version of Unicode that was produced in 1991 will say the semantic stack is still quite young. But by comparison with the classic storage in relational databases, there are still some downsides. Are there any initiatives focused on performance?
So yeah, that's a great question. Performance has very often been brought up as a limitation of the semantic stack. Okay, at the risk of looking like that I'm avoiding the question, we are more concerned about standardizing the protocol and the format for exchanging that kind of data. Okay, performance is really about the implementation. Now, as I said, we care a lot about implementation, so I will not be avoiding the question, and I think it boils down to what I said. Currently, native RDF. First of all, there's no clear evidence that native RDF implementations are lacking in performance in general. I know that some people report that kind of experience, and maybe they're not using the right RDF database, or maybe they should not try to use an RDF database. As I said, in many cases, it makes much more sense to keep your relational database that has the performances you need, and use something like OnTop, for example, which uses R2RML on top of your appropriately named on top of your relational database, and keep the performances of the relational database for day-to-day use, and use RDF only when it's necessary.
Okay, Solid is indeed an interesting initiative, but not so visible. How do you see its development? An audience member is asking.
So I don't know how visible or not visible it is. I mean, from my biased perspective, it's everywhere at the moment. But
You've a
that's
unique perspective, though.
the filter bubble and
Yeah.
so on. So no, it could definitely use more visibility. I sincerely hope that the creation of a working group and the fact that it becomes a proper standard makes it more visible. I really like the initiatives of some governments in Belgium, in Finland, being followed by other governments, and I heard through the grapevine that this might be happening soon in other European countries. So yeah, I think this is just the beginning, and I hope that the creation of the working group will be triggering more visibility around Solid.
I mean, to an extent, we'll have to wait and see. So finally, then, a question saying, well, not a final question. We've still got more first questions coming in. All these standards are transversal. What works around domain-specific data?
That's a very good question, because for a long time, the position of W3C was to restrict itself to transversal standards. So we have very generic vocabularies such as DCAT, which I mentioned, such as the PROV ontology for representing provenance data. More and more, there are requests from people coming to W3C and saying, okay, we have this domain-specific ontology, we would like to make it standard. And the fact is that there is a lot of expertise around ontology standards and ontology design here at W3C. A lot of community groups are doing this. And so we are in the process of considering creating working groups for creating this kind of domain-specific ontologies. This is, and again, this is really some internal discussion at this point, but there is a lot of demand for that, and so this might change in the future. Although, yes, until now, this has been more about transversal vocabularies.
A last question then. Are there any working groups on personal knowledge graphs?
There are no working groups on that specific topic, although arguably the solid working group could be considered as focused on this kind of thing. There has been there is a workshop series organized by CIMIC around this very topic. I was fortunate enough to be at the second one at the beginning of this month. I'll be joining the third one at the end of March. And one lead that was discussed during this workshops is maybe creating some activity, not in the form of a working group, but at least a community group for this kind of thing. Yeah.
Web is still not catching up with RDF tech. Are there ways to mix them in a more user-friendly way?
Sorry, can you repeat the question?
Yeah, web is still not catching up with RDF tech, and are there ways to mix them, make them more user-friendly?
Yeah, user friendliness of RDF has been around for a long time. JSON-LD, I believe, has made a change. Disclaimer: I'm a co-editor of JSON-LD 1.1, so again, I'm biased in this, but. I think JSON-LD has made a lot of change. Some people argue that RDF is actually largely used on the web because JSON-LD is what powers schema.org annotations, and schema.org annotations are ubiquitous today on the web. So in a way, RDF is super largely used, even though most people using it don't know they are doing RDF. And again, that's part of what I was saying about linked data being just an interoperability layer on top of things. People are writing and copy-pasting JSON bits as they were copy-pasting HTML bits in the early days of the web. And doing so, they are actually populating the giant knowledge graph that is linked data. So in a way, I would challenge this affirmation. Although on the other way, yes, we need to make progress on user friendliness, but interestingly, RDF might not have been the immediate success that HTML has been, for example, on the web. But although RDF was designed for the web, RDF is actually much used in the background. So we have progress to make, but in a number of ways, this is still a success, I think.
Thank you very much, Pierre-Antoine, for the insight, for answering the questions, and for your presentation.